right, so I'm Derek. I'm going to be talking about services, boundaries, finding service boundaries, a few things in between, a lot about context. Everything I'm talking about is on my blog at codeopinion.com. So I actually have I think it's like a 5-6 part series. A lot about what I'm talking about here, probably some other stuff as well, just in blog format. They're kind of shorter posts, but they will probably give you a better idea of some of the things I'm talking about today if you want to dig a little bit deeper. There's also a open space tomorrow at, I think, 11 that somebody created. I think that probably revolves around the same idea of trying to find boundaries. So I'm going to try to attend that one tomorrow because I'd love hear some of your experiences and talk about some of the stuff I'm talking about today. So hopefully I have time at the end for questions. Otherwise, we can do it later in the hallway or at the open space tomorrow. So context. Context is king. I pretty much use this slide every talk. I use it everywhere because I always like talking about context first to really set the stage about kind of, essentially this talk is an experience report, right? Almost everything, my opinions are my experiences. Hopefully most of the time they're my experiences. So I want to give a little bit of a background on the things that I'm referring to, how I got to some of the ideas that I'm going to be sharing today. That way you can relate it back to some of the projects you're working on. Hopefully, if not, sorry, but hopefully there's something that you can relate to, so I can give a bigger picture about just some of the recommendations that I'm making, the things that I'm doing. So many years ago, I started working in a company and we were writing distribution software. I've actually had kind of 2 stints with this. The first one was a larger period of time, about 8 years. I left, worked, and did some consulting for a few years, and then after that, I somehow managed my way back into distribution software again. So this is the example that I'm going to be using through the talk. They're really simple examples that I'm using, but that's kind of the domain that I'm using is distribution. So at a super high level, all it really is you have warehouses or warehouses that you are purchasing products from vendors, suppliers, manufacturers, whoever, that you're receiving and then subsequently selling to customers, businesses, et cetera. So you have product coming in, warehousing, shipping it out. So we wrote a system, including accounting, that did everything ultimately. So when I say service boundary, what do I actually mean by service? I think service, like a lot of terms in our industry now, are what does it even mean? I think if we probably asked everybody what their definition of service is, I think there'd be a lot of different definitions that we're going to get. So what I want to do is kind of set the stage of what I think a service is. That's not to say that my definition is right or yours is wrong or vice versa, just so that we're on the same page. And when I'm talking about a service, we can be on the same page here. So I'm going to go back to the tenets of SOA to kind of define what a service is to me. And this was defined by Don Box in, I want to say, the early to mid-2000s, around 2003, 2004. This is when Microsoft was creating WCF. If you're not in the Microsoft ecosystem, you can also relate this to the wonderful era of SOAP and web services. So that's when this kind of got coined. And I'm going to go over all 4 of them. But the first real 3 are the important ones for the purpose of boundaries and talking about boundaries. But I'll go over all of them nonetheless. So boundaries are explicit. It's what we're trying to figure out today. Services are autonomous, which play an important role in that. The implementation side of this is sharing schema, not class. And then lastly, which is I'm going to kind of gloss over a little bit, is compatibility is based on policy. So what I mean by boundaries are explicit. You need to know your boundaries, obviously. That's what we're trying to do. But it's really defining a public defined interface or contracts of what your service does. What is its behaviors? What does it provide to the outside world or the rest of the business, the rest of the application? So having a strong definition of what the contracts are and not leaking any internal private information about what that service actually does on the inside. So the 4 key points here are business capabilities, ownership of data, and then message contracts. So the interesting thing with capabilities and data is that they really go hand in hand, right? You want to encapsulate data with behaviors. This is kind of not necessarily intuitive all the time because a lot of people will have services that do one or the other, not necessarily both. So what I mean by that is if you have a service, it's not really a service to me, but that has behaviors, does some capability, but does not have any authority over data, that's not what I'm talking about when I'm talking about a service. To me, that's just a function. Maybe something that you can access, but it's not a service. It's just a function. It takes data in, sends data out, has no authority over actually any data behind it. And then conversely, if you have data with absolutely zero behavior and capabilities, then it's just a database. And I had a conversation with a couple of people last night. We were talking about kind of the evolution, I think, of software and the advancements we've made and some of the places where we haven't made advancements. And I think this is one of them. I'd be curious to know later on when we talk to people is the number of places you see where whether you're doing it or other people are doing it, creating kind of thin, say we have a web app that's doing thin CRUD operations over top of a relational database or even a document database. I'm not exactly sure what the purpose is if it has zero behavior. A lot of databases now have HTTP interfaces. If you're creating a web app, just access the database. You don't need to create some whole other set of some thin layer facade that's really doing the same thing that you could be just hitting a database. A great example of this is a couple of years ago, I was using DocumentDB, which is now known as Cosmos DB in Azure. And it has an awesome HTTP interface that gives you a lot of the stuff out of the box that you would be implementing yourself, creating a thin web app. So it gives you things like concurrency built in. There's ways to deal with it. There's caching built in with e-tags. There's a lot of functionality built into it that you would otherwise be creating yourself. So if you have data and you have no behavior, it's not a service to me. It's just a database. So services are autonomous. I think this is getting a little bit more popular, the idea of autonomy. When I think about autonomy, I immediately think of vehicles right now and autonomous vehicles or semi-autonomous vehicles. And the idea here being is that we want a service to control itself and have as little as outside impact as we possibly can. Its internals, however it wants to do it, it's up to it. So what I mean is it's self-governing, they're replaceable, and I put no external dependencies here, but really what I mean is limiting the external dependencies. And I don't mean external dependency in that, like, oh, you have a database that's within that context. No, I mean outside services, whether you own them or not, limiting what those actual dependencies are, especially synchronous dependencies, which I'll get to here. And the idea with replaceability is that's kind of the thing people think most about with services is, hey, I can just spin new ones up, take ones out, deploy them independently. And that sounds great depending on how you're actually communicating with services. So share schema not class. Again, this is from Don Box in 2004. So if you are lucky enough to remember the SOAP era and you remember WSDLs and you remember all the definitions, that's a contract, right? That is your XML definition that ultimately you would use with CodeGen to create your client side of that equation. And usually that XML was defined by your actual services that you've created. If you want to think about it more recently with something like gRPC, you're creating protobuf files, that's essentially your contract, right? You're creating what the behaviors are, what the methods, the requests and the responses are, the inputs and the outputs. As well as if you are creating web apps and you're using OpenAPI, same type of idea. You can use, there is CodeGen for OpenAPI as well, but that's essentially the contract, right? Like that's, instead of sharing classes and whatever technology that you're using, you're actually just using kind of a shared contract. And obviously not tech specific. I think where the big part that we got lost with contracts is backwards compatibility. Thankfully, with HTTP services, backwards compatibility got a little bit easier. But I think with things back in the SOAP era, from what I remember, backwards compatibility was almost an afterthought most of the time when people were creating changes. And I think that stems a lot of the disgust for SOAP, were changes and contracts changing and breaking clients. So this last one is just compatibility is based on policy. And really what this means is your service is going to have certain constraints, whether it be security, how it communicates with other services. All this means is that basically two services need to agree in order for them to interact with each other. But this last one's not necessarily so much important for how I define a service right now. Okay, so service boundaries. Why do we even care about service boundaries? We've defined what a service is, or how at least I'm describing a service right now. Why do we want service boundaries? Eric mentioned it yesterday in the keynote. For me, the reason being how I see everything is everything I've done knowingly or unknowingly in architecture has always been revolving around coupling and avoiding coupling as best as we possibly can. So this is the big ball of mud. Eric mentioned it yesterday. And whether you want to view this diagram as each little kind of bubble here as being a class, a module, whatever, the idea being is that it's showing the dependencies between everything in the system. If you've ever run a static analyzer or some type of analysis on your code base, if you haven't, I'd highly recommend it because you can see what it looks like in terms of dependencies. But ultimately, the idea is being everything's going to turn into a big ball of mud, which has coupling all over the place. With the big ball of mud, I think there's a little bit of a connotation that a monolith is a big ball of mud, but it doesn't necessarily need to be. And I also think a monolith nowadays has a negative kind of aura around it, which I also don't think is correct, because I think you can create monoliths that are probably are better suited than what this is, which I call this the distributed big ball of mud, which is the idea of taking a monolith that we have that's turned into a big ball of mud that has dependencies all over the place, and we're trying to stop that high coupling. But all we've really done is ripped it apart into separate processes and decided it was a better idea to make these calls over HTTP, over the network, than in process. And I'd argue this is actually worse than it being all in process. And the reason being is because if you're dealing with this now, you have multiple services that are all calling each other via HTTP or gRPC or whatever the case may be, something synchronous though, is that logging is harder, tracing is harder, debugging is generally harder. I just find this, it has its benefits, but it definitely has some drawbacks versus having one single process. So I don't know necessarily a lot of times this is actually a better solution. So self-governing, I think Eric mentioned this as well last night about, the advent of services. Everybody's fine now with there being multiple databases instead of one massive database and one massive schema, which I think is probably pretty true. So the example I like to use here is now that services have their own individual database and have the particular data that they kind of are the authority over, we don't ever do this generally anymore, right? We try not to have services interact or call directly to other services databases. So my analogy all the time when I'm talking about this is at my house, I have a fence, and I have my shed in the back, and my lawnmower's in the shed. If my neighbor wants to borrow my lawnmower because he needs to cut his grass, he can't jump the fence and break into my shed and steal my lawnmower. That's not how it works. He has to come to my front door, and he has to ask me for the lawnmower, and then I'll go get it for him. That's essentially him using the contract, the API that I've defined, which is my front door. He can't just go and access something behind my back. With autonomy, though, that's being taken a step further, which is we're saying, no, he can't even do that. Really what we should be doing is having some schedule that he's aware of all the time, and that I let him know when things are happening that he can access a lawnmower when he needs to, rather than coming to ask me, so I can tell him when it's available. So everybody's talking about messaging and events. I'm going to go over it just briefly because I'm going to be using this in some examples related to boundaries. So for those unfamiliar, the general idea, though, is instead of using request response and something over HTTP that we're making synchronously, we're going to be using events instead. And our services are basically emitting events of things that have happened. Not internal, necessarily exposing internal events, but taking internal events and defining them as something public that other services or the outside world actually might care about. So what that looks like is our application is sending something to whatever it may be. It could be a message broker, an event stream. That's irrelevant. But the idea is that you're publishing events. So in the warehousing system, if I were to, for example, have a sales service and a shipping service, if the sales service does anything important, maybe like an order is placed, we have an event that we publish, and then the shipping service actually may react to that at some point. But the idea here being is that the producer of the event doesn't really care about the consumers. It's just publishing the event. We define the contract, which is the event itself, that, hey, we're going to publish this. When this happens, here's how it's going to conform. Here's what it's actually going to look like. But we don't actually care who consumes it. So with coupling, where I'm really going with this is instead of having this big ball of mud or this distributed ball of mud, what we're really trying to do is take these things into little balls of mud. So we have these little services that are autonomous, that aren't generally, preferably, not talking synchronously to each other, but rather communicating through a message broker, an event stream, et cetera. Right? So we're trying to limit the actual calls synchronously from one event to the other. The reality of it is that there's going to be some behaviors that you need that you're actually going to need to call synchronously, and you're not going to be able to get away from it. That's why I keep using the word prefer asynchronous versus synchronous. But again, you're not always going to be able to get away with it completely. So this sounds kind of counterintuitive because if you think of the word service generally before all this, my immediate reaction is, so I think of cloud services, I think of AWS, which we use, or Azure, and I think of, well, every service they have is request response for the most part, right? Like everything you do, if you're hitting whatever service they have, generally you're making a request, you're getting a response. But that's not how I think of service. I generally think of a service as a self-contained thing that's really emitting events and trying to limit all the synchronicity that you have between trying to do orchestration. So if I were to sell a service in one phrase, it is that it's the authority over a set of business capabilities. And really behind that, like I said, capabilities and data go hand in hand. So it's also the authority of specific pieces of information. But the key here is business capabilities. So when we're talking about boundaries, what are the capabilities of a service? And ultimately, how do we figure out where we want to define a service, we think we have some idea of what it may be, but where does something actually live? Now, I'm going to go over 4 of the things that I found over time have helped me. I will say that a lot of it's in hindsight that you kind of get the aha moment of maybe you've put something in one place and it doesn't really belong there. And then after a little bit of a pain or a breakthrough in discussion, you realize, oh, actually this behavior belongs somewhere else. And I don't think that's necessarily wrong that you're kind of have to evolve over time. I don't think it's necessarily the idea that you're just going to get it right immediately off the bat. There is some evolution to being able to change where behavior and data actually lives. So language, context, perspective, and questioning. And there's kind of a thread that goes between all of these. So I'll go over each one and kind of give examples along the way here. So language. Eric also mentioned this yesterday when he had the slide of, and he was showing the word value, and then that the word value changed depending on the context. So exactly that. Language for me is probably the biggest indicator of where a boundary is, and it's very subtle sometimes. So if I were to say the word crane without much context, what would you think of? Well, if I were here at a construction conference or I was using the domain of construction, well, then clearly you may think of the image on the left. Otherwise, if we were in some nature event or whatever the case may be, maybe you think of the image on the right. But this is the case in distribution. Depending on who you're talking to in the organization and what their roles are, you can use words that mean very different things to completely different people within the organization. And this has been the case in every domain that I've been in, and right now I'm in transportation, and it applies there as well. And it applies in the health sector that I've been in, distribution, transportation, various forms of transportation. It's always the case. In distribution, the example I use all the time is a product isn't a product. And what I mean by that is, in this picture, there's a product on the shelf. If you were to ask somebody in shipping or in receiving, and you're talking about a product, they mean something completely different than somebody in accounting. It means something completely different than somebody in purchasing or in sales. A product isn't a product. Depending on your context and the behaviors and how you use the system, it's not exactly the same thing. So what I mean by that is the word price. If you are talking to somebody in sales and they use or you use the word price, it's automatically a given because sales is customer centric. They're talking about the sale, like the sale price, their selling price. If you then go head over to purchasing and you talk to somebody there, because they're vendor centric or manufacturer centric, when they use the word price, they're like to somebody else, to sales, that's actually cost. But they both use the word price interchangeably, but they mean completely different things to each one of them. Same thing in accounting. When they're talking about price, they're generally talking about the sale price, and then they'll actually refer to cost to talk about the purchase price. So these subtle, just you're talking to somebody, you're talking about price, it means completely different things to different people. And when that happens, when you make that distinction that they're really talking about different things, it's because they are, and there's probably a boundary there. So again, context plays a key role of understanding somebody's context and the words that they're using. Probably the best advice I've ever had in my career, or one of the best pieces of advice I had, is always understanding the person you're talking to's context. Especially where this came from was my frustration once, talking to customers and feeling like they were frustrated with how the system was working. And it wasn't until stepping out of my shoes and thinking I knew everything about the system and how it should be, and really getting into their shoes and understanding what they were actually trying to accomplish and really understanding their context, that I have a lot more empathy for what they were trying to do. So I think in kind of the quick social media world now, you can easily see snippets everywhere of, oh, well, somebody will say something and then it said, oh, it's taken out of context. And really the idea being is that the way it was interpreted is different the way than it was intended. And there's no way to get around this other than really trying to truly understand the context of which somebody's in. So again, in the purchasing and sales, you kind of need to know both to make the distinction between a price, a sale price, and a vendor price. So words matter. That's like my biggest go-to is just really trying to fundamentally understand the words people are using, how they're using them, and how it relates to other people in the org. So perspective. You could think, oh, well, isn't this the exact same as context? And I'm going to take this completely in a different direction, which is more technical. So perspective is we can often think of kind of two modes, I think generally, is our development view and the view of the users. So what this is, and again, I'll have a link to this in the slide, which you can get when I post it. This is the 4+1 architectural view model. So if you're unfamiliar with this, it basically describes various ways that you can actually look at a system. So there's the logical view, which essentially we've been kind of talking about now, is end users, how they use the system, trying to understand like their point of view. There's obviously our view, the development view, which is on the top right. And this would be more along the lines of your, say, source control repository, how you organize code, your source control in your IDE or your editor. That's your development view. The bottom right is the physical view, which is how you ultimately end up deploying this. And then the process view is the communication, integration between the physical view. And then the +1 stands for the scenarios, which are in the middle, which basically are the use cases of the entire system. So the reason I bring this up is because with the advent, I guess, of microservices, this is my perception, is that we've turned the development view and the physical view into the same thing, generally. I'm not saying that's all the time, but I feel like that's where we're headed, where we have a project, we have a solution that we've created, we have this in our editor, we ultimately build that through whatever build pipeline, and we turn that into some deployable artifact, whether that be an image, a container, whatever the case may be, but we take, like there seems to be a one-to-one relationship right now between a development view and a physical view, which I think is a little bit odd. But luckily, I think there may be a turn for this. So again, I live in the .NET world, and in .NET Core 3, there's this new concept of a hosted service, which basically allows you to host in the same process multiple different services. So again, in that particular case, you would have, for example, multiple different development views. Maybe you have different solutions, different projects. But when you deploy them through the build process, they actually all get hosted in the same executable, which you can then turn into a container, however you want to deploy it. But the idea being here is that don't necessarily think about where you put something in source code and how things are going to interact between services. If you need to make synchronous calls, that they actually need to make HTTP calls to begin with. They actually could be in process. So questioning. This one took me a long time to get over. It feels like when, at least in my experience, I've had the opportunity to, again, go into a lot of businesses and talk to everybody within the org. I know that's not the case in a lot of situations, but if you do get that opportunity and you do get to sit down with people in accounting, and which I said this last night to somebody as well, the people that I find the most insightful are generally in accounting. I'm not exactly sure why that is. I think it's because they see the inflow and outflow of money everywhere and they can kind of trickle it down. But the thing with questioning is, I had this thing where I just never wanted to ask dumb questions or what would be perceived as dumb questions. Because you kind of come in there, especially if you're in consulting, and you want to look like you know what you're doing. But the reality of it is some of the dumbest questions, or what I thought were the dumbest questions, were actually the most insightful. So I'm going to give a really kind of contrived example because we're using distribution. Is if we had a sales service and we had maybe some warehousing service that kept track of the products, the sales actually need the product quantity. If you're creating some sales screen that you need to be able to through purchase through like some orders, sales actually need quantity. So at first, my initial thought, being naive, would be yes, because you don't want to oversell anything. But that's actually not even the case at all. But I think the reason why I thought this is because somebody that posted this question. So this was like last week on Reddit. And I got wind of this through Jimmy Bogard, who has been here the last couple years, I believe. He actually replied to this comment. But the question really was, I had this data model, and I want to implement microservices. Should I create a service for each table? And Jimmy's answer was obviously no. But the idea being, and I think this is somewhat prevalent from the people I talk to, is that there's this idea that if you have an entity in the system, say it's a product, that product in its entirety can only live in one place, meaning all the behavior, all the data needs to only live within one service. And I think that's the biggest hurdle for people to overcome, is to realize that that does not need to be the case. Yes, you want the authority to be in one place, and you want specific behaviors to be only in one place, but there's nothing wrong with denormalizing some of this data and it existing in multiple places. And the idea of having, for example, a product actually be a product, like I said, a product isn't a product, so it could actually live within various services, or the concept of a product can live in various services. So does sales need the product quantity? Well, we've already determined that price and cost are difference between sales and purchasing. So those are going to be completely different ideas of a product. And maybe we have a catalog, which is just a database. There's no behavior, it's just a database. It's not even a service. And we share the SKU across the three to kind of identify them. But the thing is, does sales need the quantity? Well, that seems like maybe I just could assume this. I'm really naive at the beginning. And then I start talking to people in the organization. And the reality of it is I turn to find out that the idea of quantity in the system doesn't even exist, really. So if I said, hey, there's a number of this particular product with this SKU, there are 100 of them in the warehouse or across the warehouses. That's still not really accurate, because the reality of it is that the true quantity on hand of a physical goods in a warehouse is actually the physical goods in the warehouse. The number in our system is a best guess, maybe stale at best. And the reason being is because product gets stolen, product gets damaged, And for various reasons, what you actually think you have and what you really think you have are kind of two different things. So sales actually has the concept of ATP, and it stands for available to promise. So available to promise is a function that allows sales to understand what they think they'll have in the future or when you actually want to purchase something. So it's a combination of what we think we have in the warehouses, what we have purchased from our vendors or manufacturers, and when we think we're going to receive those. And if I have a particular sale that I'm going to make and I need to deliver these by X date, what's the purchase orders that we have out there that we're going to receive by then? So that's essentially what ATP is. So no, they don't necessarily need the quantity. What they need is ATP. So if we have our boundaries and we decide, okay, well, there's these various things going on, and we have a purchasing service, we have a sales service, how do we do that without making synchronous calls to figure out ATP? Because what we would need to do is we would need to call the purchasing to figure out what's been purchased. We need to call synchronously the warehouse and invoicing. But rather than doing that, what we can just do is simply, if we're following asynchronous events, we can just pick up the relevant events that matter that can calculate ATP for us. So if purchasing has an order that they've placed through a vendor, they submit that event. If warehousing makes an inventory adjustment, which generally comes from, you might have heard this before, they'll do inventory counts, like stock counts, where they'll literally count stuff on the shelves. So those are inventory adjustments. And if our process is that we bill the customer and then we ship it out, well, maybe there's an order invoiced event that invoicing places, and then we can pick up that as well to kind of take out what we think is in ATP. So if I wouldn't have asked dumb questions originally, and this is very true in this particular example, I probably wouldn't have known about ATP for later on in the process when I figured it out really early on because of just seemingly just asking a lot of questions and not being afraid to look stupid or ridiculous that you think you need to ask these wonderful magical questions that's going to give you all these epiphanies. That's the biggest one for me that I still struggle with is just knowing what your assumptions are and validating them by asking the questions even if they look completely ridiculous. So with some implementation here, I've been talking about coupling, and I advocate this all the time because to me it's been probably the best technical thing I've done in recent years that's helped coupling, no doubt. So it's the idea of thinking about vertical slices within a service and not necessarily layers. So even if you're not using services and you're thinking about just like a general application, a monolith in general, this still applies. It's thinking about vertical slices and layers. And what I mean by that is typically in a service or an app, you have layers that span the entire thing, right? So if we're talking about a web app, you have some authorization, some validation. Maybe these things live within the framework that you're using. You have some data access. And maybe you have a data model, maybe you have a domain model, and then some data storage behind that. But instead of thinking about these layers in this fashion of a service or an app, the idea really is thinking about an individual set of capabilities, like a capability itself or a set of capabilities that itself is a feature. And that's what's living in your service. Now, I'm not saying get rid of layers. I'm just saying that the individual layers and the responsibilities of what a feature does lives inside the feature rather than the entire service or the entire app. So what that looks like is this. So this is a single feature, and it controls, if we're talking about a web app again, it controls its controller or however the input is from the web. It has its own auth, it has its own validation, and its own execution model. And maybe, again, it has some shared cross-cutting concerns like a domain model, or maybe you had validation that spans more than one feature. But the idea being is that, again, we've taken our big ball of mud, now we have services that are little balls of mud, and now we have even smaller balls of mud, which are individual features, because they're dictating what its dependencies are. And this is really useful, and we do this all the time in the software I'm currently writing, and this is actually a legitimate example. We went from using ASP.NET MVC and Web API several years ago, and once ASP.NET Core came out, we decided, okay, well, we knew where ASP.NET and .NET was going, which was nowhere, and the future was .NET Core. So we wanted to make that change as best we could. And because we use kind of feature vertical slices, it actually allowed us to do this feature by feature and not have to do it an entire service at a time or an entire application at a time. We literally could change things one at a time. It's also applicable to any other part. So for example, if you use an ORM and you want to switch to how maybe in one particular feature you're doing that, and you don't want to use the ORM, you want to maybe use direct drivers, or you want to change something to a completely different data model, you can do that like slowly progression instead of having to do some big bang, even if it's now within a smaller service. So what that looks like in my head visually is I have these services that have a certain set of capabilities. Those are the features. We've broken down our coupling into individual features. And I said, like, there'll still be cross-cutting things that you have, like validation or a domain model. And I'm not saying you shouldn't do that. It's just more about splitting the individual layers within a feature. So when we think about these services and what the boundaries are, it's grouping all these related things and keeping them together. So once you determine, for example, that there's, say, a sales service and a purchasing service, and they each have their own database, again, not being afraid that you can't have some purchasing information in sales, but just realize that stuff is like essentially a cache and it can be denormalized there. You don't need necessarily one product and it has to live in one spot. So one thing that I've kind of completely glossed over is UI. So if we have services and we're trying not to communicate kind of in a request response fashion and trying to do it more asynchronous through events, yes, you still have UI, so therefore you still are serving request response somehow, and it's going to be through UI. So there's a couple different ways you can do this. This is taken from Microsoft has a sample application they call eShop on Containers, which is their kind of demo sample app for microservices, which is basically this little kind of like e-commerce shopping where they have like .NET products and t-shirts and stuff on it. But it shows various different ways, and they've actually have different implementations of it through the project. And one of the methods that they use, so they have a mobile app and then they have a web app. And in their web app, they use ASP.NET Core MVC, and this is what they call their monolithic UI. So their monolithic UI is essentially, it's doing all the composition. It's calling all the individual microservices to fetch out whatever information it needs. So on the image on the left, if you could see, for example, like the products that are listed, like kind of in the page with the coffee cup and the sweaters and stuff, maybe that information is coming from one microservice. Maybe then the pricing's coming from a different service. But they're doing all that composition in server-side rendering UI in ASP.NET Core MVC. So there's benefits and trade-offs. I believe I have a link to this as well because they go into more detail about what some of those are. This is from it as well. This is the idea of a composite UI, and you can see how this is getting way more complicated. But the idea of this is a screenshot of Amazon on the left, and the general notion here is that you're going to have components or individual widgets that are going to talk to microservices, and those themselves are going to do the composition. So it's almost now as if you have a microservice individually for a set of components, and they're going to do the composition. So they may call multiple other microservices to build out that UI. If you're obviously using something like React or Angular or Vue, whatever the case may be, this probably fits more in line with maybe how you think of things if you're thinking of everything as individual components and kind of building out a UI. So I do link at the end of this, again in the slides, Jimmy Bogard, who I've mentioned before. He has a 4 or 5 parter on kind of the pros and cons of different ways of doing this and his experiences doing it. So I'd highly recommend checking that. It was pretty insightful for me to kind of see his experiences as well as what mine are, because they're very similar in the approach. It's not one's better than the other. They just have trade-offs, obviously. All right, so I'm just going to kind of go over these again just in a little quicker way. Is with language, context, perspective, and questioning. For me, again, a lot of it's been in hindsight, and I said it at the beginning, I don't think you're necessarily going to get it right at the beginning. I think there is something to evolving kind of boundaries, evolving the model. And hopefully, if you are coupling in the way that I've talked about, it ends up being a lot easier to make these changes. Once you make the insights of, oh, actually, this behavior doesn't belong here, we're probably better off served pushing it somewhere else. And like I said, if I ever have to give advice to people, my best advice, which was given to me, is understanding the context of the individuals that you're talking with to try to gain these insights. Not just their context, but relating it to other within the within the system that you're actually building. 4+1, so for perspective, is not everything that you develop in its silo needs to be deployed in its silo. Because that can dictate a lot on how you actually build everything. Do you need to have RPC? No. Maybe you want to have RPC and you're better off not doing it over a network. Maybe you want it to be in process for speed reasons or whatever the case may be, but at least you have that option knowing that how you have it in your repo and how you have it in your IDE does not need to necessarily get deployed that way. Questioning, don't be afraid, my biggest thing, don't be afraid to look like an idiot and ask questions that just validate assumptions. Because that can take you a long way. And then again, if you're talking to people and they take it the wrong way, I think over time they'll realize why you're asking these questions to get things right, to actually ultimately help them in creating the system that's going to ultimately help them. So I keep using the word prefer messaging over RPC over synchronous requests. Again, you're obviously not doing this in the UI, but between services, try to limit the amount of synchronicity that you have between them, and rather let them be autonomous, let them emit events, subscribe to those events. And one thing I never really brought up there is those events, document what those events are, understand what the events, the contracts, and how you can evolve those events and version them, which is a whole other topic. Data authority is, don't be afraid to have a product isn't a product. Don't be afraid to have the concept of a product live in multiple services. Yes, you want those certain pieces of data to only live in one particular place, like to be the authority there, but that can be cached elsewhere, especially like, for example, if we're talking about a product name or something like that. Maybe it's just in the database, but you can have that live in multiple services. Don't be afraid to split things up. They don't need to always be in one service. So see, these are some of the resources that I mentioned up, the 4 tenets of SOA. Again, this goes back, from where I found the actual HTML, but again, this goes back from like 2004, I think. 4+1, architecture review model, the composite UIs from Jimmy. So again, I'll have these on my blog at codeopinion.com if you want to talk about these. Just a reminder, so then tomorrow at 11, there's kind of, I think, an open space talking about this and techniques and other ways to do it. So if you have any questions, hopefully I see you there, because I'm going to try to get there as well and talk about some of this stuff and get some input from everybody else. So thank you.